Welcome to Fun Maths. Today we'll be looking at an Olympiad Maths question while trying to find easy solution to the question. The question says 3 to the power of x minus y is 25. 3 to the power of x plus y is 125. So what is 3 to the power of x over y? So our focus is to find the value of x and also to find the value of y. If we've gotten that, then this would be a piece of cake. Before we find the value of x and y, I'm going to rewrite 25 and 125 with the base 3. That's how I can solve it. Here I'm going to introduce something called the inverse property of exponent. So the inverse property of exponent, if we have b to the power of log k base b, please take note, b and b, they are the same term, and then we have another term k, which is the log term. This whole thing is equal to k based on the inverse property of exponents. So I'm just going to rewrite 25 and 125 using this idea. 25 is the same thing because we are looking at the base 3. So I can say is 3 to the power of log 25 base 3. So you see that we have 3 here, we have 3 here, the same thing b, and then we had k, everything was equal to k. So if we have it in the same way, everything is equal to 25. In the same way, I can write 125 and say it is 3 to the power of log 125 base 3. Now, I can rewrite what I have as my question. So we have 3 to the power of x minus y. And now instead of 25, I can write 3 to the power of log 25 base 3. Let's call this, okay, let's leave that. And then we have the other one, 3 to the power of x plus y equals 125, which is 3 to the power of log 125 base 3. All right. So since we have the same basis, which is 3, we can equate the power, the index, by the laws of indices. We can equate the index. So we have x minus y equals log 25 base 3. Also, we have x plus y equals log 125 base 3. X plus y equals log 125 base 3. All right, so I'm going to call this equation 1 while calling this equation 2. All right, so now what do we do? I'm looking for x and y, remember? And remember simultaneous equation. One of the ways we solve simultaneous equation is by elimination method. In this case, I'm going to be adding both of them. You could do the elimination, yes, to get y. But I'm looking for x, so I'm going to add equation 1 to equation 2. If you add equation 1 to equation 2, you have x minus y plus x plus y, and that is equals to log 25 base 3 plus log 125 base 3. All right, so let's remove our brackets. We have x here, like terms, so we can say x plus x, and then minus y plus y equals, now for the laws of logarithm, this is a side note, if we had log a plus log b, is the same thing as log a times b, which is log ab. Okay, the only condition is that they must have the same log base, let's say c for both of them. Do you understand? So this log term has the base 3, same thing here with the base 3, and they are adding both of them. So it means that we can say it's the same thing as log 25 times 125 base 3. So x plus x is 2x minus y plus y is 0. So I can say it's equal to 25 times 125 is 3125. So this will be log 3125 base 3. All right. Now, this also looks problematic. I'm looking for the value of x. So if I just divide both sides by 2 here, I might get it difficult. So what I'm going to do is change this term, 3125. Follow me. In the same way I did this, the inverse property of exponent. Now, 3125 can also be written as log or can also be written as 3 to the power of log 3125 base 3. Remember from our inverse property of exponent. Alright? And 3125 is 5 to the power of 5. So I can write this as 3 log 3 to the power of log 5 to the power of 5. And then we have base 3. And for logarithm, one of the properties is that if you have log a to the power of b, it's the same thing as b log a, meaning you move b to that side before the log. So I can move 5 before this logarithm. So we'll be having 3 to the power of 5 log 5 base 3. So what's the importance of this? Let's take this back to this problem. So 2x will be equal to log, instead of 3125, I'm going to write everything here since this is equal to 3125. So we'll be having log 3 to the power of 5 log 5 base 3. And then remember, this log has the base 3. I hope you're following. So now we have 2x equals to log 3 to the power of 5 log 3 5 base 3, and then with all base 3. How do we solve this? Also, another law for logarithm, if you have, I mean, it's the same law with this. When you have the power b, you move it before the log. Now, everything here is the power. So we'll be moving this before this log term. Do you understand? So it means that 2x will be equal to 5 log 5 base 3. Then before we have our log 3 base 3. Okay, now another law for logarithm, if you have log a base a, it's equal to 1. If the log term and the base is the same, that's equal to 1. So it means that log 3 base 3 is 1. Remember, these two look like they are multiplying. We're multiplying the both of them. And so 2x will be equal to 5 log 5 base 3 times 1, right? And you know that when you multiply anything by 1, it brings back the same thing. So we have 5 log 5 base 3. So to get the value of x, now we divide both sides by 2. X should be equal to 5 log 5 base 3 over 2. That is for the value of x. How do we get the value of y? Remember also, when you do simultaneous equation, you can also do substitution. So we've gotten the value of x. We are going to substitute this into any of the equation. I'm going to be using equation 1. So from equation 1, we have x minus y equals log 25 base 3. X is 5 log 5 base 3 minus y equals log 25 base 3. I'm going to clean this part of the board now. So now we are going to collect like terms and make y to stand alone. So we'll be having minus y equals, we already have log 25 base 3. And then we can say subtracting 5 log 5 base 3. That is minus 5 log 5 base 3. So this is minus y equals 25 is 5 to the power of 2. So I can write this as log 5 squared base 3 minus 5 log, oh please, pardon me, x is divided by 5 log 5 base 3 divided by 2 divided by 2 divided by 2. Pardon me, please. Alright, so this is 5 squared, and I've already told you, you move the power before the logarithm. So we'll be having minus y equals 2 log, because 2 moves here, 5 base 3 minus 5 log 5 base 3 over 2. So how do we solve this? Well, I want to make them have the same denominator, making 2 the LCM. Okay, so it means we have minus y equals 2, because the denominator here is 1. All right, 2 divided by 1 is 2. 2 times 2 is 4. So this is 4 log 5 base 3 minus, this is already 2 divided by itself, and then that is 5 log 5 base 3. Now 4 minus 5, because they have the same logarithm term, same logarithm base, well, we can subtract them. Okay, it's like saying minus y equals 4 minus 5 log 5 base 3 divided by 2. Alright, so we have minus y equals minus 4 minus 5 is minus 1. So that is minus 1 log 5 base 3 over 2. Now we don't need to write minus 1, we just need to write minus, because the 1 is not that important. So you just have minus log 5 base 3 over 2. Is that the value of y? Not yet, because we have a negative attached to y. So to get the value of y, multiply both sides by minus 1. We multiply this by minus 1. Same thing here. This is going to cancel out this minus. Y will be equals to log, this will also cancel out, 5 base 3 over 2. So we've gotten the value of x and y. How do we get 3 to the power of x over y? So to get 3 to the power of x over y, we have 3. I'm going to make this big, very big. X, remember, was 5 log 5 base 3 over 2. That's for x. And then we are dividing it by y, which is log 5 base 3 over 2. So I think that should have even been bigger. Okay, so this is 3 to the power of x over y. And now we have the general divisor, which is this division. When you are dividing like this, you are going to look for something called multiplicative inverse. It means that you're going to be multiplying instead of dividing, but we'll be inverting the denominator. So this will be equal to 3 to the power of 5 log 5 base 3 over 2. Now we'll be saying times, instead of log 5 over base 3 over 2, it will now be 2 over log 5 base 3. That's what we call multiplicative inverse. So 2 is going to cancel out. And then if you look at the board, we have log 5 base 3, log 5 base 3. This will also cancel out. We are just left with what? 5. So the answer is equal to 3 to the power of 5. And 3 to the power of 5 is 243. So we'll be having 243 as our final answer. This is the answer to this Olympiad Maths question. If you enjoyed our video, please do well to subscribe to this YouTube channel, like this video, and share it so that others can benefit from it. Till we meet again, it's goodbye.